Good afternoon. Thank you so much for spending your after lunch sessions with us. We'll try to be as engaging as possible, so let's call it tiredness of after lunch will be offset by the presentation. My name is Shachar Hirschberg. I'm a product manager at Amazon GuardDuty. I help customers secure the AWS environment, and specifically with a focus on active threats.
Hey everyone, thanks for joining. I'm Sujay Doshi, and I'm another product manager with GuardDuty with the same mission as Shahar said.
So just by a quick show of hands, just curious, how many of you have heard about GuardDuty before? All right, so pretty much everyone, great.
Yeah,
who is familiar enough with GuardDuty to come up to the stage and talk instead of us? Just joking. How many of you are using GuardDuty as a customer? Almost everyone, amazing. And how many of you are using all of GuardDuty's protection plans? Okay. How many of you are using some of them? Okay, kind of like the majority. And how many of just using base GuardDuty, just like the core service itself? Okay, so it sounds like all of you pretty much used a mix of like GuardDuty itself plus the different protection plans. Yep. Amazing. So we have a lot to talk about today, and well, thank you, Sujay. And we will talk mainly about multi-stage attacks that can target your cloud environment and how GuardDuty helps you detect these kind of scenarios. And to get there, we will walk through what is GuardDuty and especially the different protection plans that we have in place to help you understand how GuardDuty can put it together and detect attacks that span not only, for example, across identity, but also network and data plane of services such as S3, control plane of services such as EKS. Because what you see really in today's attacks is that they span across multiple dimensions and attack vectors. So a bit about the agenda for today. We'll start with covering the threat intelligence that powers a lot of the detection capabilities that we have in GuardDuty, and then continue to speak about the different options that you have on when to use what. Give a little peek on the behind the scenes on how we are able to detect detections and do it in an effective manner, and share a new capability that we released yesterday. It's a major expansion of a capability we released last reInvent, and I hope many of you have heard about it before. It's called GuardDuty Extended Threat Detection, and it's focused primarily on detecting these multi-stage attacks. So starting from the threat intelligence side. And just to give a quick intro on GuardDuty, I know many of you are familiar with it, but GuardDuty is our threat detection service. It's a managed offering that helps you detect active attacks, threats in your cloud environment. And it's a fully managed offering from the perspective of getting access to the relevant data and enabling the service itself. Once you enable GuardDuty, and you can do it via the console or CloudFormation or API with just a few simple steps, GuardDuty automatically gets the information it needs, which is cloud-relevant telemetry, such as CloudTrail logs and other types of logs that we will cover in a moment. And from that moment, it continuously monitors your cloud environment for threats and uses multiple techniques, including a vast usage of machine learning, and we'll talk about how this machine learning works a bit later today, as well as stateless and stateful rules to be able to detect threats in your cloud environment. We also use threat intelligence, both threat intelligence curated by Amazon, as well as threat intelligence shared with us by third-party vendors. And from the moment you enable it, you don't need to update GuardDuty, maintain it, patch it, or do anything that relates to the management of the operation of the service itself. We do it automatically on your behalf. A bit about the scale that we operate. GuardDuty, and I think this room is actually a great representation of it, is used by tens of thousands of customers across virtually every industry and geography. We protect millions of AWS accounts, and as a result, millions of EC2 instances, S3 buckets, EKS clusters, and so on and so forth. And this unique vantage point allows us to detect not only common threats, but also emerging patterns that we start to see across potentially a subset of our customers, and then quickly add detection. So if this kind of attack pattern will become popular, let's put it this way, we'll be able to quickly detect it across our customer base. We have 3 sources of threat intelligence, and many more, but this is a sample that we use. The first one is called MIFRA. MIFRA is one of the largest neural networks in the world, and it contains billions of nodes and edges that we use to map DNS requests across the visibility that GuardDuty and really AWS has. And that allows us to detect suspicious and malicious domains, oftentimes weeks before we see them come up from other threat intelligence providers. So very big vantage point, a lot of visibility allows us to detect suspicious, let's call it domains and other activities early. Another service capability that we have inside of AWS is called MedPot. MedPot is a global network of honeypots that helps GuardDuty detect activity that can be malicious. If you haven't read yet the blog on MedPot, I would highly recommend reading it. It's a great read. If you just Google AWS MedPot blog, you'll probably get it as one of the first resorts. And just to give a bit of sense on the scale GuardDuty operates, last Prime Day, we analyzed trillions of events every hour, an increase of 30% from last year. And we continue to operate in this kind of scale on a regular basis. And for Prime Day, I know I was responsible for some of this activity. I bought a lot of things. Maybe you guys bought some things as well. But seriously, though, this scale allows us to operate as a very effective threat detection service because we analyze so much activity and have visibility into many things that are happening across the AWS environment. So a bit about what is this analysis that we actually do. GuardDuty, and that's on the left-hand side of the screen, process multiple telemetry sources that range from CloudTrail, which is basically representation of what happens in the control plane of the cloud, who did what, where, and when, to network activity such as VPC flow logs and DNS logs, and a variety of additional telemetry sources that helps us get more in-depth protection and detection for services such as databases and container services. So for example, we process or are able to process S3 data events and detect data exfiltration and data destruction attempts as a part of it because we can see all the get, put, delete requests that are being made. And these attempts to perform data exfiltration and destruction can be a part of a potential ransomware attack. We just don't call it ransomware because we don't know if someone asked for a ransom. In addition to that, we have visibility into runtime activity that is powered by the sensor that we have that you can deploy. That gives us visibility into runtime activity for EKS clusters, EC2 instances, and ECS Fargate clusters. And we also have a variety of other protection plans that we will cover more in depth in the second part of the presentation. But conceptually, the way that GuardDuty works is really ingest all of these raw logs, whether it's the more generalized logs like CloudTrail or VPC flow logs, or more service-specific logs such as S3 data events or RDS login attempts, to be able to detect specific threats that you would probably want to discover as early as possible to respond to. And from your perspective, all of this processing of telemetry results in over 175 types of findings, ranging from suspicious IAM activity to crypto mining to data exfiltration and many more. And these types of findings can be consumed whether by the GuardDuty console, so you can go into the GuardDuty service and act on them there. You can use Security Hub, which is our CNAPP offering, and as a part of it, aggregates findings across accounts and regions, so you can respond on them within the Security Hub console. And you can also use Amazon Detective, which is our investigation service, or send the finding outside and use, for example, your SIEM or ticketing solution to work on these findings. And to be able to send findings outside, you can use EventBridge to do a more event-driven architecture, or export the findings to S3 buckets and pull them from there. And one last thing on the unique security value that GuardDuty has is that the processing of all these events, all the raw telemetry, can't be interrupted by an adversary from the outside, because we get these log sources, whether it's CloudTrail or VPC Flow logs or any of the other ones, straight from the source, because we are a native service, which means that even if an attacker comes in and hopefully not, but start compromising your environment, even if they turn off CloudTrail to try to evade activity, it doesn't matter to us, because we always get the logs straight from the source. Even if they turn off all the different log sources, we will still get them and report to you on any malicious activity. So we have all of these things, and it's great. It provides a very broad coverage for cloud security threats. But what we've been hearing from customers really over the past year is that they get a lot of alerts from GuardDuty, as well as many other security tools that they have. The one thing I never hear from a security team is that I just don't get enough alerts. My day is kind of like half empty because I just don't have what to do, right? All of us are overwhelmed with alerts, and we get so much information from so many different sources. So we wanted to make it easier for customers to connect the dots between the different alerts, what we call findings, and help you identify the most important threats, the most pressing one with the highest confidence to be true positive, such that if you only do one thing when you start your day, you will start by looking at these findings. And this is why in December, we released GuardDuty Extended Threat Detection. This capability uses AI and ML to connect the dots between different signals, whether they are strong signals, which are finding, or weak signals that are events that are potentially suspicious, but not suspicious enough for us to send a finding to you, because we don't want to overwhelm you. And we correlate all of these signals across a 24-hour time window and resources to detect attacks. And we call this, the output of this capability, attack sequence findings. It's a new type of finding that we released last re:Invent. And these attack sequences have critical severity. It's severity, if you are more familiar with GuardDuty, we had severity up to 8 in the past, and this is severity 9, it's critical. And these attack sequences encompass multiple events organized on a timeline, and we'll see a quick demo of them pretty soon. And the idea is to help you focus primarily on these type of findings, which represent the most important threats to your cloud environment, the most pressing ones. Now, just a bit about the scale of it. Since we launched this capability last re:Invent, it's been running successfully, and we worked with many customers to help them if they had any potential threats to their cloud environments. Over the past 3 months, we generated 13,000 attack sequences across the millions of AWS accounts that we protect, which means that if you actually look at the average, it ends up being less than 2 findings per account for a period of 3 months. And we talked about the problem of getting too many findings and not knowing what to do with them. So when you get this type of finding, on average, you'll get 2 of these every 3 months. So that translates to 8 of these per year. That's a pretty manageable volume. So when you get one of these, the recommendation from us, and we strongly recommend it, is to address them as early as possible. I can say that the true positive rate for these findings is very high because we validate them with customers many times. And it's a really managed approach. It's enabled by default. You don't need to do anything to enable it. There is no additional cost, which can be nice, to use to get this capability. The only thing that you do need to enable is the underlying protection plans, and we'll talk about that in a moment. And we use the broad visibility we have to continuously update the detections powering these findings and detect emerging threats as well. So what's new? Yesterday, we released a major expansion to this capability, and it now supports EKS clusters as well. And that means that when we see multiple actions being taken and in relation to an EKS cluster, we will create this critical severity, which would be attack sequence for compromised EKS cluster, and it will correlate activities that relate to the EKS cluster automatically across EKS audit logs, runtime activity, as well as the cloud control plane. So to translate it to GuardDuty protection plans, we will correlate activity from foundational GuardDuty because we might see some discovery activity from CloudTrail that doesn't even relate to EKS yet, but then we start seeing suspicious activity in EKS control plane and suspicious activity from EKS runtime monitoring that looks into the activity on the host itself and correlate it all together into a unified story that you can then address. All of these findings are mapped into MITRE framework, MITRE attack framework. So we know that, again, you have many security tooling that you use, and MITRE is a good way to understand this type of finding amongst all the hundreds that I have. What does it relate to? What did the attacker did so far in the attack chain? And assess the importance and the remediation that you want to do as a result. In terms of the scenarios that we cover 3 scenarios now. Compromised credentials, which are the #1 initial attack vector to cloud environments. Compromised data, for data residing in S3, and that is most importantly for many customers, the most important organizational asset. And the one I just mentioned, compromised EKS cluster. And together it provides you a pretty wide visibility that supplements the already coverage you have with GuardDuty across compute, control plane, and data. Now, let's move to the fun part, and I'll show you a demo. Okay, if the text will be too small, just let me know, raise your hand or something. So we are now in the GuardDuty console, and as you can see here, this is the general dashboard that we have in GuardDuty, and within it you can see if you have attack sequences. This is specifically a demo account, so you have many attack sequences there because I generated them on purpose. But typically the ratio that you see would be probably 1 to 1,000. So for each 1,000 GuardDuty findings, you can expect 1 attack sequence, give or take. It varies according from customer to customer. Now you have a dedicated page called Extended Threat Detection, and this page allows you to see, maybe I'll zoom in a bit more, allows you to see that and validate that you have the relevant protection plans to get the most out of this capability. So for each part of GuardDuty, we share what scenario is covered and which finding type corresponds to this scenario. For foundational GuardDuty, it will cover compromise related to credential misuse, and then you'll get the IAM compromised credential attack sequence. Now, what is new in this page, if anyone has seen it in the past, we had the related protection plans, and the first protection plan that was relevant when we started at reInvent was S3 protection for coverage on compromised data, but now we added EKS protection and EKS runtime monitoring, and that allows you to detect compromises that relate to your Amazon EKS clusters and get the finding type of EKS compromised cluster. And let's take a look at this finding type and learn more. So I'm just sorting by severity to find the attack sequences, and we can go to the first one. This attack sequence covers a potentially compromised Kubernetes cluster. You can see that it has a critical severity, and it correlated 13 different signals. So just to go back to what we discussed earlier, instead of you having to analyze 13 different findings and understand and analyze how they relate to each other, we do it on your behalf. And in this case, the activity started around 3 p.m. and ended around 4 p.m. So we correlated across an hour. And in real clusters, you'll probably see the activity happening across multiple hours, even though the velocity of attacks have been increasing across the industry. When we see new events happening, we update the finding. So this finding would be the source of truth as it relates to this specific attack. You don't need to look at other findings because we update it automatically. And on the left-hand side, we provide more of the security intuition behind why GuardDuty flagged it as such a suspicious activity. So we can see that multiple MITRE attack tactics and techniques were used, ranging from privilege escalation all the way to execution and impact. And GuardDuty also identified DNS queries being made to crypto mining domains. Now, there is a lot of information within the attack sequences, but an easy way to kind of pivot and understand what or which resources are involved is to go to the resources tab, and there we group by the events per the AWS resource type. So in this case, you can see that an EKS cluster was compromised. If you click on the different MITRE tactics, you can see the different GuardDuty findings that relate to this particular cluster. And in this case, we see privilege escalation, impact execution, very suspicious. And we provide the information about the resources itself as well. So you can see the exact ORN. You can even see the EC2s that relate and power this cluster, and pivot to the EC2 or EKS console to learn more about the resource. We can even see that within the cluster, a specific pod was compromised, and we get information up to the container level of the specific container that was likely compromised. You can click and see the different activity that happened associated with container, and even get information such as the container image used, and that mainly is relevant for supply chain attacks. And we can also learn that an access key was involved, and we saw 7 different signals associated with this access key. So we have a likely compromised access key, as well as likely compromised EKS cluster. And then we can go and dive deeper on the different signals, which are the timeline that we build automatically to learn about the activity that happened. So we can see that a privileged container was launched on this cluster. We get that visibility from the EKS control plane. And likely what happened is that someone compromised an access key, whether it was exposed publicly or in another way, launched this privileged container, and then started performing crypto mining on it, because we can see that a Bitcoin-related domain name was queried, and we can even go and see which specific domain was queried. And it happened as a result of a new binary that was executed. Now, we even provide information on the specific processes that were involved in this specific attack because we correlate the activity from both the EKS control plane and the runtime monitoring, which allows you to get very high fidelity information that you can then take action with. And in this case, you can see that an XMRig, which is a popular crypto mining tool, was executed. So as you work through these findings, you can look at the timeline, understand the story and how it evolved. That's really the right-hand side. And on the left-hand side, we provide the context on the MITRE tactics that were involved in this event, as well as the different indicators, which are the security intuition on why GuardDuty thought this is such a suspicious activity. And in this case, the indicators entail multiple MITRE tactics and techniques that were involved, crypto mining processes, and you get the exact processes that were executed. They then communicated with the crypto mining domain. And if you want to learn more, you can see the specific actors from the role that was involved to the Kubernetes user, to the different processes that were involved as part of this event. So by using these new attack sequences, you can really focus your effort on the highest priority threats and get very rich contextualization that helps you understand exactly which entity or identity misused your cloud environment, the actions they took, how they did it, and then what you can use is the remediation guidance that we offer. So here on the left-hand side, we have the remediation tab, and there we provide guidance for each finding type on which actions you should consider taking to respond to and remediate the event. So from the moment you learn about the finding all the way down to remediating it, GuardDuty can help you detect suspicious activity or malicious one and respond to it effectively. Now, I would like to invite my colleague Sujay back to the stage, and he will do the second part. Got it? Click again.
Okay, perfect. All right, thank you, Shahar, for your detailed insights into how GuardDuty can help you modernize detecting sophisticated compromised clusters running in your EKS deployments. Good afternoon and welcome again, and thanks for joining us. Now for the rest of this session, we'll talk about some of the patterns and kind of the best practices that we see in the field from different organizations in terms of GuardDuty adoption of different protection plans and features that it has. It can become overwhelming generally to kind of think about what does good look like for me. So hopefully in the next few slides, we'll try to provide some prescriptive recommendation based on the patterns that we see, and hopefully that aligns. So really depending on multiple different options that we'll talk about, the end goal is to help you determine what really does good look like when it comes to enablement strategy for GuardDuty and its various protection plans. So the first pattern that we see is where customers want to enable all the features in all AWS accounts, in all AWS regions where they have the workloads running. This really is the gold standard for kind of centralized security administration. Truly a set and forget model wherein you don't need to worry about getting protected with GuardDuty as and when you'll have ephemeral workloads and accounts that are coming up and decommissioned. There'll be automatic protection for all the features that GuardDuty today has the offering to detect threats in, and any new workload that gets attached to the accounts where you have the features enabled, it automatically protects. And there's a 30-day free trial for every account, every feature, every region. So that essentially provides a mechanism to evaluate the usage and also validate the efficacy before you go all in and basically go to paid usage in production. The second pattern or the model that we see is selective enablement, wherein customers would only want to enable different protection plans in GuardDuty on specific accounts where they have those targeted workloads running. Now, this is also a good option for customers that have segmented environments and a specific compliance that they need to achieve depending on their operational requirements. And this kind of helps strike a fine balance between targeted protection and cost management. And you don't need to worry about GuardDuty spend for accounts where you specifically do not require the different protection plans that GuardDuty has. But the benefits, seamlessness, and ease of use translate from the first option to here as well, where you'd be able to use 30-day free trial for all, again, accounts where you have enabled the feature, but every region. And use it to kind of validate the efficacy and kind of the spend levels. And the third pattern that we see is kind of a better together approach. Depending upon the workloads that you have, and again, kind of different segmented environments, we also see customers using GuardDuty findings because of the virtue of being first party and having native visibility to data for some of these core AWS services. A lot of the customers leverage the findings from GuardDuty and would integrate it to their downstream SIEM and SOAR workflows, or basically any downstream system that can consume data from, let's say, EventBridge. And this makes it seamless for having a holistic threat detection and incident response workflow where GuardDuty findings can contextualize and enrich the data into those systems, and customers can kind of reduce that mean time to respond essentially by using multiple different tools, facilitated with seamless integration with GuardDuty. So now in this slide, we'll look around kind of diving slightly deep into what each protection plan that GuardDuty has to offer, what are the specific things that we monitor, and what are some of the prerequisites that make sure that you're effectively able to leverage some of these offerings from GuardDuty for threat detection. So the first one is foundational sources, wherein GuardDuty monitors. By default, when you enable an account with GuardDuty, you're automatically enabling foundational threat detection, encompassing of monitoring from your CloudTrail management events, that is the control plane or the API interaction layer for different AWS services that are part of kind of the deployment. And then we'll also be monitoring the network layer with the VPC flow logs and DNS query logs from your Route 53, essentially giving you visibility into the network-based threats and some of the IAM level compromises that GuardDuty can detect in terms of the anomalies. Then with S3 protection, very much recommended for when you have workloads wherein you're storing regulated data or customer data in S3 buckets. And what this entails is monitoring the data plane API events from CloudTrail specifically targeted to your S3 buckets, giving you the capability to detect volumetric exfiltration type scenarios involving S3, and a key source that's part of the attack sequences that we launched at reInvent last year with S3 data compromise. Now moving towards kind of the workload monitoring with EKS audit logs, we simplify the ability with which GuardDuty can give you the compromised scenarios wherein someone is accessing your cluster. So kind of monitoring the control plane of your Kubernetes cluster deployments. You can essentially decide to enable it on accounts and all the clusters that are existing, or in future when they are running, GuardDuty automatically, again, without any source service side configuration, you don't need to vend the logs, you don't need to collect the logs. We'll ensure that as soon as you enable these features with a single click and multi-account management using organizations, we'll start collecting the data and then providing you visibility into the threats that we detect. And there's no agents required for this one. With runtime monitoring, on the other hand, we built a lightweight eBPF-based agent so that we can give you visibility into really what's manifesting when, let's say, compromise occurs in these container environments. And you can only go so far without getting visibility into the host. So all the way kind of piecing these signals from when we see in CloudTrail, the control plane interaction, to something that we see with Kubernetes deployments, the control plane activity when someone creates a cluster, establishes containers, exploits the misconfiguration of different permissions. Now, what really is happening in those container deployments? That's what runtime monitoring enables you to do that. There's automated agent management. So because we use agents, a big pain point generally, GuardDuty provided no extra cost, the ability to manage those agents, and helps you build a unified threat runtime monitoring or runtime security program wherein you can use similar, or it's basically the same eBPF-based agent that can be then used depending on whatever compute or multiple hybrid compute services that you use from GuardDuty, such as EKS on EC2, ECS workloads on EC2, ECS workloads running on Fargate, and your traditional EC2 workloads. And prerequisites entail, permissioning. In case of EC2, if you want automated agent management, then we recommend checking SSM-based permissions, because we use that for automation and generally making sure that you have the agents available for the instances you want. One of the other benefits generally we hear from the field, and something that's important to be realized, is in addition to getting visibility into the runtime compromise and some of the targeted protection that we do just looking at the runtime data, customers also see benefits in reducing their spend levels, because depending on the network architecture, VPC flow logs kind of becomes a big spend contributor to the GuardDuty bill. So with this runtime agent, whatever instances you have the agents deployed, GuardDuty will not charge you for processing the flow logs. We'll still process them, we'll still generate findings, so you do not have a single point of failure in cases where the agent stops working because it's at the maximum capacity. We do not want you to be regressed with your abilities to detect network-based threats. So we'll still process them, but you would not pay for them. And that's significantly high benefit, and obviously not discounting the advancement in capabilities that you get with different kinds of threats that we detect. Now moving to RDS protection, this is specifically where, again, without using any agent, holistic, a multi-account management for all your existing databases, and any new database that you spin up will give you login anomaly-based detection, so giving you visibility in case of misconfigured security groups where your database is running. If you allow public access, we'll give visibility into what are the intentions that we see from Tor exit nodes or successful brute force attempts. And then we eventually want to give or expand this to give other threat scenarios detection capabilities for data exfiltration and data egress. Today it's supported for Aurora and RDS Postgres, and eventually this will also be something that we want to provide for other different RDS engines. With Lambda protection, we help you, again, without any configuration or layers that you need to add to your Lambda functions. We give you visibility into the network-based data that we collect from those function executions, both VPC and non-VPC Lambda functions, so that you can get coverage for threat vectors such as unintended use of Lambda functions for crypto mining, as an example, or your supply chain attacks, wherein your Lambda function is now becoming a proxy for C2 communication as the channel. While all of these sources that we talked about had streaming data or logs that we essentially got from these services, with malware protection, that we launched about 2 years ago at Reinforce 2022. That's 3 years. We basically, for the first time, provided an agentless capability to scan your EBS volumes that's attached to your EC2 instances and container workloads. So in addition to getting signals from different threat detection techniques that we have, encompassing for all these different sources, malware protection for kind of the EBS or the EC2 helps you verify some of the network anomalies that we see. The way we built it was to automate the workflows that generally the analysts would use in case when you see a finding which indicates communication to outbound, I don't know, C2 domains, right? You might want to verify on what really is happening in that workload for this communication to happen. Is there a malware? And generally, before this feature being GA, what customers did was to take a snapshot and then run with whatever malware scanner they have at their disposal. And it was a tedious process. We essentially automated that entire thing and additionally added the ability to also initiate on-demand scans so that you can increase the fidelity and improve your investigation workflows or for forensics. Just last year, we expanded this capability, that is the malware protection or malware scanning capability, to also provide a fully managed offering to protect your untrusted upload applications that have S3 as the backend. Imagine data that's being sent from your external vendors to your buckets or internal users who are uploading data to S3 bucket that will be externally available. In both these cases, if you do not trust the data provenance or you do not trust the entities, there can be a serious risk where organizations can either be accepting malware if they're not able to verify, or be malware distributors if some compromise happens from internal users and the next thing you know, the image that's uploaded is actually a malware and external users are downloading them, right? So this feature kind of automates this entire process, helps you build secure pipelines in a fully managed manner. And you can do this enablement at a bucket by bucket level, because again, not every S3 bucket qualifies for being an untrusted upload application bucket. And you can even use this feature, by the way, as a standalone feature. Everything else we talked till now does require you to enable the foundational GuardDuty so that we can correlate more such signals. But this is a very targeted kind of application developer persona use case. And you can essentially just use GuardDuty to secure your data pipelines using this malware protection feature for S3. So now with the first, the few slides that we looked before, the first one was kind of recommendations and prescriptive guidance on what does good look like when it comes to enablement strategy. Then we looked and we dove deep into different protection plans that's available in GuardDuty, what each of it entails, and why is it that you should use with the coverage that you can get. This slide attempts to provide a mental model or essentially helping you make a decision process from the workload profile. So depending on whatever kind of the workload profile you have in your environment, let's say if you're using EC2 and S3, the recommendation is to use foundational and then combine that with malware protection for S3 and the S3 data plane event monitoring. If you're container heavy, there's control plane monitoring and kind of within the containers with runtime monitoring. So you can basically get coverage for some of the findings that we generate using the attack sequences in extended threat detection. And again, remember one thing, more features that you enable, more security signals will get, and more better the model would be into kind of correlating it. So in case of a real compromise, we'll have more artifacts to kind of contextualize the information, ultimately helping you to do targeted remediation, exactly knowing what all are my indicators of compromise and where all do I see something bad that's happening instead of kind of having to decommission the entire workload itself. If you're using serverless, if you have a serverless first strategy, then we'll cover you through foundational Lambda protection, and then even for ECS workloads that run on Fargate, GuardDuty makes it seamless for you to kind of ensure that every task that's running or that will be running in your workload, we can inject a sidecar to kind of do the runtime monitoring, right? And then without heavy lifting of having to update the task definition, you just use the task execution role with the right permissions, and any task that's part of that group, will inject the sidecar. And then for kind of data platforms specifically focused around protecting customer data or involves kind of configurations that you store in databases, you can use RDS protection, S3 protection, malware. And then in general, if you're kind of in regulated or zero trust, the recommendation we provide is, just enable all, right? That way at least you have that peace of mind in everything that GuardDuty has to offer to protect you and secure you. You have that control set enabled. So this was a lot of prescriptive guidance, and what is it that we see as patterns in the field talking to all of these different customers. The rest of this session can either be very interesting or not so interesting, depending on your inclination in knowing kind of what the secret sauce is. How can GuardDuty effectively at the scale that we just kind of, Shahar mentioned around kind of 6 trillion logs every hour, imagine the scale at which kind of we are operating and how it effectively and in a sophisticated manner is able to kind of do some of these threat detections. While we have a lot of heuristics and rule-based and threat intel-based pattern matching detections, but the ML and AI basically helps us differentiate between unexpected and abnormal behavior from a not yet seen behavior, but an expected one. Because with the scale and the data volume with some of these protection plans that you can imagine, such as flow logs, your S3 data plane events, your CloudTrail logs, it can easily, if you were to generate atomic findings, we basically will be contributing to the alert fatigue problem, right? And we'll talk about kind of one class of such model or one ML model that GuardDuty uses to kind of help gain security relevant signals out of all of this data set. And we do this primarily using representation learning. So the goal of representation learning is essentially to map each entity, such as an IP address, the IAM user, the principal ID, all the different data events or the attributes that we see in these events that represent an entity. Representation learning helps map each entity by encapsulating its behavioral characteristic into that embedding vector. So think about these vectors or points or points in some unidimensional space, wherein as and when we see the events, we ingest the data, establish a normal baseline for these profiles, and each of these vectors will have kind of the behavioral characteristics, generally what APIs a user uses, what buckets does it communicate to, what ASN does the user log in from, what are the general instance types we see an account be associated to. So these are some of these representations that we encapsulate in vectors, and a primary contributor of these vectors is essentially give us the ability to differentiate the unexpected behavior from a never seen occurrence, but kind of business as usual. And so let's kind of see how in action this helps. Let's take the example. We see a user, Nikki, associated with star instance API that we see in CloudTrail events. And the ASN, we see the user kind of performing this API is some Argentinian telecom company A. Now from the same user, for the same instance, for the same resource, for the first time we see stop instance, and it's from a different ASP. Now technically, this can be considered as a never seen event for Nikki. And then if you were to generate kind of atomic indicators or atomic findings, we basically can kind of show this to be an abnormal or an anomalous behavior in the scope where the system's kind of running. We never see Nikki to be using stop instance API and never see Nikki kind of performing activities from Argentinian Telecom B. But representation learning ensures that these vectors, because start instance and stop instance typically are kind of related APIs, and if it's on the same resource, generally the system learns that this is a normal behavior, and in some special region, you'll also see kind of these ASPs by the virtue of their geographical context kind of related to each other. And hence, with all of this information, we get a signal that this event's not kind of anomalous. It might be for the first time we see this, but it certainly is not abnormal because of some of these vectors that are close points in the space. Now, another class of ML models is actually something that powers the extended threat detection feature that we talked about. Here, we talk how representation learning helps us extract kind of relevant security signals from this trove of data. But then these security signals, with the singular findings that we generate, kind of becomes a lot of related findings that customers individually have to investigate. And that's kind of one of the primary pain points extended threat detection was created to kind of solve for, where we combine some of these related security signals to provide a more contextualized and a prescriptive kind of investigation process, wrapping with all the indicators of compromise that we see across these 10 different findings as an example. And we'll kind of try to dive deep into how it does under the hood. So when we think about some of these different security signal groups, like these are nothing but findings that are generated, and you would kind of be looking, before extended threat detection, the individual findings were nothing but security signals. And then we'll group some of these security signals into security signal groups that basically can be thought of events you see commonly from a user or from a principal ID or IPs. We'll group all of these security signals we see on the same entity, and then we'll do the clustering of kind of these related signals together, but then which cluster is actually a higher priority finding that something GuardDuty should generate an output for as an attack sequence. We do this using a ranking ML model, which has encoded the security engineer's intuition in it. Generally, without kind of the ML model, how we see security responders look at any event and triage, they'll basically ask these questions, like, does it involve high-risk API? Is there an unusual instance type that's involved? Does it have low reputation IP address? Do we see any proxy anonymizers or VPN solutions that are kind of used as part of this? Is the user agent among suspicion? And these are some of these questions that typically a security engineer or a security responder would ask in order to kind of effectively triage whether this is a true positive or false positive. What we have done is essentially we encoded all of this security domain expertise or the security intuition into what we call as marker library, which is basically a series of these encoded functions that every time there's a security signal group or a cluster that we need to evaluate, the ranking model kind of essentially leverages the questions encoded as markers in the library. And some of these marker libraries essentially will have binary decision of yes, no. So in order to kind of get more prescriptive guidance from the model into which actually is a sequence that's a higher priority or higher rank, because all these clusters will be stack ranked, they'll be evaluated against this marker library with encoded security intuition package and functions. And then the model will evaluate on how many of them kind of see yes or no with some of these markers. And then on top of that, each will run another ML model to generate a ranking score. So what really happens in the ML model it basically learns how to aggregate the marker, aggregate the marker's disposition from kind of the data that it has. It actually discounts the contribution of markers that commonly kind of disagree with each other. So indicating that they are not of higher efficacy in actually generating a valid ranking score so that can be prioritized. Because the reason we do this, sophisticated ranking and clustering is essentially we want to prioritize those events of interest, what we call as attack sequences. This model will automatically reward the markers that tend to agree with each other. Like if it's a low-risk API, generally seen from an ASN that's part of, let's say, an embargo list or something that's not observed for the organization. Now combine, if all of these security signals that we are evaluating, continuously these markers agree to the general kind of holistic, then the model automatically increases the weightage for these markers and will kind of listen more in order to generate a ranking score. Discounts the contribution of marker that's always on, one mechanism with which it locally understands the context of what's really, again, maybe abnormal in the general context, but if you localize kind of the context, it's fine, business as usual, because it looks like that's how kind of the workload's operating in their environment, in a customer's environment. And then we also kind of get incident data with all this different threat intelligence and the integration we have with internal threat intel feed and IOCs. So we'll reward the contribution that tends to agree kind of with known incidents. So this is, in a nutshell, things that we have that helps make the detection capabilities sophisticated for extended threat detection and attack sequences that we'll generate. All right, I think we already saw the demo. These are some resources for you to kind of get more detailed insights into GuardDuty and different offerings. And thank you for your time.